All right, guys, this is number 3 on the review. It says evaluate cosine of arc cosine 2.7. So let me just tell you that cosine and arc cosine, they cancel out. Inverses always cancel out. So your answer is just 2.7. Now, if you want to understand what's happening, let's go ahead and do a simpler one, such as sine, and then I'll do arc sine of square root of 2 over 2. So you always start on the inside. Where is sine equal to square root of 2 over 2? What angle? 45 degrees. So this can just be written as 45 degrees. Now, what is sine equal to at 45 degrees? What's the y coordinate there? Yep, square root of 2 over 2. So that's the answer. But you could just skip all of that and just cancel, cancel. That's your answer. Okay, so inverses always cancel out. So even if this can also be written as cosine, and then in parentheses, cosine inverse of 2.7. This means the exact same thing. So you'll see it both ways. You could also write this as sine, and instead of writing arc sine, you can write sine inverse square root of 2 over 2. And those cancel out, leaving you with the answer. Okay, number 4 on the review, you have arc cotangent at negative square root of 3 over 3. So whenever you think of cotangent, you need to think of tan. And remember, tan, you can look at tan in the 4th quadrant, and we call that negative 90 degrees. And then the 1st quadrant, which is positive 90 degrees. So that's the only place where arctan exists, tan inverse exists. And in the same way, that is where arc cotangent exists. We're just gonna look in the 4th quadrant to the 1st quadrant, okay? So whenever you think of tangent, you always need to know that tangent is y over x. So that means cotangent is x over y, okay? So let's think about the unit circle. I'm just gonna do the 1st quadrant. So this coordinate here is square root of 3 over 2.5. This is at 30 degrees. And at 60 degrees, it's the same thing, but just switched. 1/2 square root of 3 over 2. Now I want to know where arc cotangent is square root of 3 over 2, square root of 3 over 3, but negative. So it's going to be same thing, but down here, since it's negative. However, let's evaluate this. So if I want cotangent, you have to do x over y, right? Because tangent is y over x, so cotangent is x over y. So let's try this one. Let's see if this is the answer. You'll put x, which is square root of 3 over 2, times the y, or let me divide it by the y. When you divide, you flip the second one and multiply. So instead of writing this, write it as multiply by 2 over 1. This cancels out, you're left with square root of 3. Is that what they want? No, so it's not this one. Let's try this one. So tangent, I'm sorry, not tangent. We're gonna try this one. So cotangent is x over y. This is x, which is 1/2, over y, which is square root of 3 over 2. Now, when you're dividing fractions, you flip the second one and you multiply. So I'm gonna write this as times 2 over square root of 3. The 2's will cancel out. You're left with 1 over square root of 3. And you cannot leave square roots in the denominator. So you're gonna multiply this by square root of 3 over square root of 3. So your answer is square root of 3 over 3, which is what they want. So that's the 60 degrees. However, this is a negative square root of 3 over 3, so it'll be down here at negative 60 degrees. So that's the answer, negative 60 degrees. So 60 degrees is where cotangent is equal to positive square root of 3 over 3, right? Because we put x over y and we did the algebra. And that's what we got. However, we have to be negative, so we're gonna be down here. Same distance away, negative 60 degrees. So that's the answer. Okay. Any other ones you would like me to do on the board? This is number 12. So first, let's find the period. The period is always 2 pi over the absolute value of b. And just so you remember, this is what the transformations look like. Okay. So what we have, this 3 is in this spot right here. This 3 is your b value. So I'm going to erase this b and put a 3 there. So that means my period is 2 pi over 3. So I'm going to put that right here on the fourth tick mark. And now you need 4 equal sections. So I'm going to divide 2 pi over 3. I'm going to divide it by 4. So I'll do the math over here. 2 pi over 3. I'm going to divide it by 4. And whenever you're dividing fractions, you're going to flip the second one and multiply. So this is like multiplying by 1/4. And then you multiply across. So you have 2 pi in the numerator and 12 in the denominator. This simplifies to pi over 6. So that's your first tick mark. Each little section is pi over 6. So I can add another pi over 6 to get to the second tick mark. So pi over 6 plus pi over 6, that's 2 pi over 6, which simplifies to pi over 3. And then you can add a third one. This is 1, 2, 3 pi over 6, which simplifies to pi over 2. Now you can go ahead and graph your cosine function. Cosine always starts at the maximum, then it goes to the midline, down to the minimum, midline, back to the maximum. So this is your graph. And in order to get credit for this problem, you need to have all the tick marks. Right, you have to, once you find the period, you have to show me what each little tick mark is. So that if I asked you, you could tell me that the relative maximum is right here at 0, 1, and right here at 2 pi over 3, 1. You have to be able to answer those questions based off what you graphed. But if you don't have these tick marks, you don't have the full thing.
How do you know where the midline is?
The midline is your D value, which you don't have here. That's why it's at 0. We didn't have if you had like a +2, then you know your midline would be here at 2. And then you graph it like that. And it'd be up here if it was +2. Any other questions? Number 10, sure. Number 10. Okay, so here's number 10. So this is a sine bx minus c plus d. And we have an a value, that's our amplitude. Our b value is just 1. Your c value is right here, and we don't have a d value. So let's go ahead and find the period. The period is 2 pi over b, and your b here is just 1. So I know my period is 2 pi, so on the fourth little tick mark, I'll put 2 pi. And your shift, your phase shift, is you set this, what's in the parentheses, you set it equal to 0, and you solve. So this is what's in the parentheses, x plus pi, set it equal to 0 and solve. So you move pi to the other side and it becomes negative. So that is your phase shift. Okay, so let's go ahead and mark each of my tick marks. So I have 2 pi If I divide it by 4, this becomes pi over 2. So that's my first tick mark. If I add another section, this will be 2 pi over 2, which simplifies to pi. If I add another section, this will be 1, 2, 3 pi over 2. And then I'm going to shift to the left pi, since that's a negative pi. So this is negative pi over 2 and negative pi. Okay, so sine always starts at the midline and then it goes like that. So I'm going to start right here at negative pi because we moved to the left. And then my amplitude is 5. So I'm going to go up 5 from that first point, from my midline. So up 5, 1, 2, 3, 4, 5, right here. Oops. Right here. Back to the midline. Let me zoom out some. And then down 5 and back to the midline. So this is your sine graph. Your amplitude is 5. It vertically stretched 5. Any other questions? Does that one make sense? Okay. Okay, you said what would be the B and C value for this one?
Yes.
So let me write it right here. So notice B is whatever is attached to the X. So that means this is 1 over 2. So your B value is 1/2. You could see this as 3 sine 1/2 X. These are the same thing. So your B value is 1/2. So that means your period is 2 pi over your B value, which is 1/2. And whenever you're dividing fractions, you flip the 1 in the denominator and you multiply. So then this is 4 pi. So this is your period, 4 pi. So if we graphed it, this is 4 pi, that means half of it is 2 pi, half of 2 pi is pi, this is 3 pi. This is negative pi, and so on. You start right here, and you didn't have a phase shift. You didn't have a plus C or a minus C there. And your amplitude is 3, so you'll go up 3, oops. There you go. This is 3 sine 1/2 X.